Hello, viewers. Greetings to you. It is time for us to consider something important about limits. And at this stage, there are actually two things, as you can see on the screen. One is for blue, the other one is for red. And we could refer to this one as one-sided limit. Before we proceed, let's consider this particular question, which is the sine x over x. If you look at this function very well, there are two things involved about it. If you look at the table, let's plot the table. Let's compute the table to see what the function is all about. If you look at this table very well, you notice that if we put 1 in the f of x, which is sine x over x, what we get is the same thing as if we put minus 1. In fact, if you use plus 0.5 and you put minus 0.5, what we get is what is in this table. But that's not the special thing I want you to see. What I want you to notice is the fact that as s is moving closer to 0 from the negative axis, this function is tending to 1. That is one thing. Look at the blue arrow now. Let's plot the graph. So if you look at this graphical illustration of sine x over x, you will notice so many things. So let me just talk about the three things about the graph now, about the function. Number one, if you put s equals to 0, the function is undefined. So which means that this function is undefined at s equals to 0. Okay, but although the function is actually tending to 1 as x is tending to 0. What does that mean? What am I trying to say now is the fact that there are three things about this. And the first one is that when x is 0, this function is undefined. That's number one. Because by the time you set x equals to 0, you know x is the denominator. And sine 0 over 0, it becomes undefined, it becomes mathematical error. So take note of that, point number one. Then point number two is the fact that as x is moving closer to 0 from the negative axis, look at the blue line. So you will notice that as x is moving closer to 0, now we are looking at the blue arrow now. You will see that the function is tending toward to 1. That is for the first limit. For the second limit, which is the red line, for the second side, which for red, you will notice that as x is tending to 0 from the positive axis, you will notice that the same function sine x over x is actually tending to 1. So what does it mean? It means that the left hand and the right hand limit of this particular function is tending to 1. But remember that as x equals to 0, this function is undefined. It's undefined. As you can see, at s equals to 0, the function is undefined, which means that the limit at the left hand limit and the right hand limit, they are tending to 1. But at s equals to 0, the function is undefined. So let's proceed to the next video. Now we can now proceed. Let's look at this problem. We are given the graph of a function g, as you can see on the screen, and there are 6 questions. And the first one is saying that what exactly is the function when x is tending to 2 from the negative axis? That is number A. If you look at this very well, you notice that as the x is tending to 2 from the negative axis, you will notice that the function is actually equals to 3. That one is A. So question 0b. Question 0b is asking that what is the function? What is the limit of this function as x is tending to 2 from the positive axis? And if you look at this very well, you notice that as x is tending to 2 from the positive, which is from 5, 4, 3, 2.9, 2.5, 2.4, 2.3, 2.2, 2.1. As x is tending to 2 from the positive axis, the function is actually tending toward to 1. So which means that the limit of the function g of x as x tends to 2 from the positive axis is what is 1. So let's proceed to question 0c now. Question 0c is now asking us that what is the limit of g of x as x is tending to 2? But look at this question very well. It's a little bit technical. Considering the fact that the limit of g of x as s is tending to 2 from the negative axis is 3, The limit of the same function as x is tending to 2 from the positive axis is 1. And 3 and 1, they are not the same. So because the left-hand limit and the right-hand limit, because they are not equal, then it means something. It means that the limit does not exist. So let me say it again. The limit does not exist because the left-hand limit is what? Is 3, while the right-hand limit is what? Is 1. So because they are not equal, then we can conclude that the limit of g of x as x is tending to 2 is undefined. It does not exist. So let's proceed again to question 0D. Question 0D is now asking us again that what is the function? What is the limit of this function as x is tending to 5 from the negative axis? So if you look at the 5 now, you will see that as x is tending to 5 from the negative axis, the limit is 2. The limit is 2. The limit is 2. As x is tending to 5 from the negative axis, the limit is 2. Then question 0E is asking again that what is the limit of this function g of x as x is tending to 5 from the positive axis? And what is the answer? If you look at the graph again, you will notice that as x is tending to 5 from the positive axis, then the limit is what? The limit is 2. The limit is 2. So lastly, we can now proceed to the fact that what is the limit of the function as x is tending to 5? But look at this question very well. As x is tending to 5 from the negative axis, the limit is 2. As x is tending to 5 from the positive axis, the limit is what? Is 2. Then we can conclude that this function, it has a limit because the left-hand limit and the right-hand limit equals to 2. But look at it very well. Despite the fact that g of 5 is not equals to 2, but the limit is saying that the limit of that function is what? Is 2 at x is tending to 5. But if you go back to when question 0a and question 0b, you will notice that the limit does not exist because the left-hand limit is not the same thing as the right-hand limit. And if you go to question number is 0d and is 0e, you will notice that the limit of g of x as x tends to 5 from the negative axis, from the positive axis,
let's
is equals to 2.
Go straight to the point now,
so we can conclude that
what is
limit
called
exists.
intuitive definition of one-sided limit.
Actually, we say that the limit as s tends to a from the negative axis f of x is equals to L. It means that the left-hand limit of f of s as s is approaching a. This approaching here, it means that the limit of f of s as s approaches a from the left. Negative is on the left. If you look at the Cartesian plane, we can say it is equals to what? To L. Or perhaps we can make it the kind of value of f of x arbitrarily close to L by restricting x to be sufficiently close to a. With x less than a. That is just the meaning of what I've been saying. In fact, that's not all. That is the first thing I've just said is all about the left-hand limit. What about the right-hand limit? The right-hand limit is the one that has plus. It means that the limit of the function f of x as s tends to a from the positive axis, which is from the right-hand side, is equals to what? Is equals to L. Just like we've seen before. So above all, now we can now combine the two definitions together to give us the practical meaning of the limit. So we can now say that the limit of f of x as x tends to a is equals to L. There are two conditions though. If and only if both the left-hand limit is equals to L and the right-hand limit is equals to L. That is the only condition. But if you look at the first definition, you will see that it's only x tends to a. That a, it doesn't have a positive, it doesn't have a negative. Yes, of course. Look at it very well. So that only exists. The limit of a function f of x is equals to L as x tends to a if and only if the left hand and the right hand limit, they are equal. That was the reason why in the previous example, we were unable to conclude that the limit of the function exists as x tends to 2. Because the right hand limit is 3, while the left hand limit is what? Is 1. They are not the same thing. Likewise, if you remember in the previous example, as x tends to 5, the left hand limit and the right hand limit, they are equals to 5. Then we conclude that the limit exists and the limit of that function is equals to 2. Okay, even despite the fact that the function is undefined at 2. Do you remember the condition there? So please take note of that. So Based on this now, we can now conclude that the limit of any function exists if it has a left-hand limit and a right-hand limit. So let's consider the tutorial question as TQ1. TQ1 is asking us that what is the limit of f of x as s tends to 1? You know, for this particular question now, before we can conclude with the answer, we need to be very sure of the left-hand limit and right-hand limit. What am I trying to say is that as s tends to 1 from the positive axis, from the negative axis, tending to 1, what is the limit of the function? And as you can see here, for TQ1 now, for TQ1a, as s approaches 1, the value of f of x approaches what? It approaches 2. Look at the graph very well. You will see that the limit as x tends to 1, f of x is equals to 2. Then let's go to question TQ1b. As s approaches 3, from the left, you know, from the left means that from the negative axis, you will notice that the limit is 1. Yes, look at it very well. TQ1b. As s is tending to 3, from the negative axis, the function is what? Is 1. Okay? So the next one is TQ1c. TQ1c is saying that what is the limit as s tends to 3 from the positive axis f of x? And the answer is what? The answer is 4. The answer is 4. Look at it very well. Look at it very well. You see that as x is tending to 3, you know, you made the upper line. And that one is what? Is 4. Then question TQ1d is saying that what is the limit of the function as x is tending to 3? Okay, so for this TQ1d here now, you will notice that the limit does not exist because the left-hand limit does not equal to the right-hand limit. Okay, so that one is for TQ1d. And for tutorial question 1e is asking us that what is f of 3? And looking at the graph very well, you see that f of 3 is equals to what? 3. You cannot take the dotted line below. You won't take the dotted line above. You will take the one that is shaded. So f of 3 is what? Is 3. Thank you very much for watching this tutorial video. See you next again. Bye.